Good afternoon, class. Here's 4.4 optimization problems. We're going to finish it off by looking at part 2. Remember, optimization is about maximizing and minimizing. For example, find two numbers whose difference is 18 and whose product is a minimum. So first we have to define our variables. What are the numbers? We don't know. How about x and y? So the objective is to minimize their product. We're going to call it P for product equals XY. And subject to the constraint is that the difference is 18, so X minus Y is 18. As you can see, P, the product, is a function of two variables. To make it a function of one variable, we're going to solve for one of the variables here. In this case, Y, I'm going to move it to this side, becomes positive, and 18 to this side. And now Y is X minus 18. If I replace the Y with X minus 18, P, the product, becomes a function of one variable, namely X. The domain is all real numbers. Why is that? We want to minimize the product. That means 0 is okay, negative is even better. That's why negative to positive infinity. To move on with that, we're going to distribute and make it x squared minus 18x. Now we are ready to do calculus. To do calculus, meaning we're going to find the critical point or critical points. So P prime is 2x minus 18. And to find critical points, we're going to set this equal to 0. And when we set this equal to 0, x becomes 9. So we have an open interval with only one critical point. Therefore, local becomes absolute. Whether it's a local minimum or maximum, we don't know yet. We're going to figure it out. But we already know it becomes absolute because there's only one critical point. So the best course of action is to find P double prime because it's just a number. Remember, you have to evaluate P double prime at x equals 9. It makes no difference what x is. This is independent of that. It's always positive. Therefore, it's concave up. Therefore, it gives you the minimum because concave up looks like that. So this is the minimum. At what point? At x equals 9. We're going to put it back into this one, and y becomes negative 9. Therefore, the two numbers, one of them is 9, one of them is negative 9. Over here, if we had put y minus x equals 18, they would interchange. What is the minimum product? 9 times negative 9, negative 81. Let us enclose a rectangular area of 288 square feet and then divide it into 3 equal pens, equal size pens with parallel sides. Okay, we see that. What dimensions will minimize the material? All right, so what do we have to do? Define our variables, the width, the length. The width is x, the length is y. What is the objective? Minimize the material. What do we need here? We need x, 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 x. So let me just write it. And this is y. Therefore, the perimeter in essence is 1, 2, 3, 4x plus 2y. So that's the objective. Minimize P equals 4x plus 2y. What is the constraint? It is subject to the area being 288 square feet. What is the area? the width times the length, x times y. So subject to constraint a equals x, y equals 288. P is a function of two variables. If we solve for y here and put it in here, becomes a function of one variable, namely x. So y is 288 divided by x. Now P, which is a function of x and y, becomes P of x when we write 4x plus 2 times y is replaced by 288 over x. Now this is 4x, this is 2 times 288, 576 over x, or x to the power of -1. We bring it up to get it ready for the next step. Needless to say, x represents dimension, must be positive, in other words, from 0 to infinity. That would be an open interval. It's ready for the next step, which is differentiation p prime of x, which is 4 plus 576 times -1. That means minus 576 x to the power of -2. We want to find critical points. That means we are going to work on this. We're going to put this down, make it 576 over x squared. We are going to take a common denominator x squared. This becomes 4x squared minus 576 over x squared. P prime equals 0. The numerator is 0. P prime doesn't exist. The denominator is 0, which means x equals 0. It's not part of the domain. Just the numerator is 0. We are going to move this to the right. 4x squared is 576 and divide by 4. When we divide by 4, we get x squared equals 144. So x is plus minus 12, and only 12 is in between. So we have an open interval with one critical point, which makes that one critical point not only local, also absolute. But is it minimum or maximum? We don't know yet. We're going to go with the second derivative test. That means we're going to go back here. We're going to differentiate it again. P double prime, this is 0, negative 576 times -2 is positive 1152, x to the power of -3. Or 1152 divided by x cubed. The second derivative test methodology, plug in and observe whether it's positive or negative. When we plug in, we don't even have to evaluate to see the top is positive, so is the bottom, therefore it's positive. Positive means concave up. Concave up means minimum because it looks like that. So the minimum occurs when x equals 12 feet. Local becomes absolute because we have only one critical point and an open interval. So when x is 12 feet, we say a equals x times y equals 288, or y is 288 divided by x, becomes 24 feet. Dimensions, x is 12 feet, y is 24 feet. So what is the minimum material? They didn't ask, but put it in here. P is 4 times x, 4 times 12, plus 2 times y, 2 times 24, 96 feet. So we answer that also, just to be on the safe side. From a thin piece of cardboard, 8 by 8, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? What is the maximum volume? You must draw a setting and define your variables. Obviously, we have an 8 by 8 piece of cardboard. We're going to cut the corners and we're going to cut how much? Well, identical size. So we're going to call it X. So we're going to cut X here, X here, X here, X here, and it looks like this. When we cut X amount, then in the middle, we get 8 minus X or 8 minus 2X. When we fold it up, looks like a rectangular solid. And the width and length are 8 minus 2X. The height is X. The objective is to maximize the volume. Any rectangular solid, the volume is the length times the width times the height. So that is the objective. What's the constraint? Well, after we've done this, it tells us the length and the width are identical, 8 minus 2X, and the height is X. And so now we can write the volume as a function of X by replacing the length and width with 8 minus 2X and H with X. So we get 8 minus 2X quantity squared times X. We put the X first. This is A minus B quantity squared which is A squared minus 2AB plus B squared. So this is 64, the product of the 2 times 2 minus 32X plus 4X squared. And X is between 0 and 4, by the way. Why is X is between 0 and 4? Because if you go back here, first of all, if you cut it in half, you get 4. And you can fold it, but doesn't give you any box, number one. Number two, if you look at this one, first of all, X is a dimension. If you don't cut, anything makes no sense. So it has to be positive. It has to be larger than 0. Also, if you set this one equal to 0, X becomes 4. So if I choose a number larger than 4, 8 minus 2 times a number larger than 4 becomes negative. It can't be. So there are two ways to look at it. One easy way is just half of 8 is 4. It can't be. So X is between 0 and 4. In any event, A minus B quantity squared. 64 minus 32X plus 4X squared. We're going to distribute the X. We get 64X minus 32X squared plus 4X cubed. We put the 4X cubed first. We put it in descending order. I'm going to erase my work. So far, everything we've done is algebra. Now let's move on with calculus by differentiating. So V prime, 12X squared minus 64X plus 64. Because we want to set this equal to 0, we're going to factor the GCF, which is 4. If I take the 4 out, I get 3X squared minus 16X plus 16. And because 3 is a prime number, everybody, the factoring is simply 3X and X. What goes in here? 16 is a product of 1 and 16, 2 and 8, 4 and 4. Both must have the same sign because it's positive 16. So when you do that, you check the middle term. Please understand, 3X times X is 3X squared. So let me erase my word. 3X times X is 3X squared. The first one is not the problem. Minus 4 times minus 4 is positive 16. The last one is not the problem. You have to check the middle term. Let's do that. So this minus 4X. This minus 12X. Do they add up to negative 16X? The answer is yes, that works out. So there are two answers. Either X is 4/3 or 4. And as we mentioned here, 4 is not included, 4 is out. So you have an open interval with one critical point that makes it not only local, also absolute. So We are going to do with the first or second derivative test. Obviously, second is easier. So right here, it's V prime. V double prime is 24x minus 64. The second derivative test says plug in. So we're going to plug in and observe whether it's positive or negative. That's all it does. So we're going to plug in 4/3. V double prime of 4/3 is 24 times 4/3 minus 64. 8 times 4, 32, minus 64 is negative 32. It doesn't matter negative what. What matters is that the sign is negative. Negative means concave down. Concave down means maximum because concave down looks like that. So maximum occurs when x is 4/3. So if x is 4/3, what is the length? What is the width? 8 minus 2 times that. 2 times 4/3 is 8/3. So I'm going to write this is 8/3. So this one I'm going to change it into 24/3. And I get 16/3. Same unit. It was 8 inches here. This is 16/3. And what is the maximum volume? The product of 4/3 and 16/3 and 16/3. You do the math, you end up with 10^24/7 cubic inches. Precise answer using fractions or a mixed number format, 37 and 25/27. A stereo manufacturer determines that in order to sell X units of a new stereo, the price per unit in dollars must be P of X equals 1,000 minus X. The manufacturer also determines that the total cost of producing X units must be C of X equals 3,000 plus 20X. Find the total revenue. A few elementary algebras. Number one, the revenue by definition is the price times the number of units we sell. So simply put, multiply them, you get 1,000x minus x3. Total profit, again, elementary algebra, revenue minus cost, just by definition. Revenue, which is 1,000x minus x squared, minus cost, which is 3,000 plus 20x. We are going to distribute. This becomes negative 3,000. This becomes negative 20x. And these two combine, and we put minus x squared first because we want to put it in descending order. So far, everything is elementary algebra, and the profit function becomes minus x squared plus 980x minus 3,000. Now we're going to do calculus. How many units must the company produce and sell in order to maximize profit? First and foremost, I want to remind you, as far as the domain is concerned, must be 0 to infinity. Can it be 0? Yes, we are not producing anything, but then we are not in business in the first place. So it has to be larger than 0. And sky is the limit. So that's an open interval. So to do the calculus, we're going to differentiate P prime. It becomes minus 2x plus 980. And to find the critical point, we set it equal to 0. And x becomes 490. So we have one critical point, and we have an open interval. Is this going to maximize or minimize? We don't know yet. We do the second derivative test. P double prime is simply negative 2. We are interested in the sign. Negative means concave down, means maximum. We are interested in the sign. I can't emphasize this enough. So maximum occurs because it's concave down and it looks like that. We're done with calculus. What is the maximum profit? Well, we go back to this step. Maximum profit is minus x squared plus 980x plus 3000, plug in 490. So profit at 490 would be minus 490 squared plus 980 times 490 minus 3000. You put it into a calculator, you get $237,100. That's elementary algebra. Also, what about the price per unit? Well, P of x must be 1000 minus x. Plug in, and you get 1000 minus 490, or $510. That's the price per unit that must be charged in order to make this maximum profit.